Heavy metal contamination in soils is a serious issue globally. Silicon looks really promising for mitigation, and it uses a clever sort of two-pronged strategy. It works both outside the plant, in the soil itself, and inside the plant once absorbed.
Okay, let's start outside. What's it doing in the soil to protect the plant?
Externally, applying silicon can actually increase the soil pH, make it less acidic. This change encourages heavy metals like cadmium, zinc, copper, lead to form precipitates with silicate.
Precipitates, like they solidify.
Essentially, yeah, they form less soluble compounds, metal silicates, which means the metals are less available for the plant roots to actually take up. It's like locking them away in the soil.
That's smart, blocking them at the source.
Yeah.
But what if some metals still get in? What's the internal strategy?
Inside the plant, silicon can affect how metals are transported and where they're stored. It can help compartmentalize them, maybe in the cell walls or vacuoles, keeping them away from sensitive metabolic processes.
So even if the plant takes some up, silicon helps manage them internally.
Exactly. This allows the plant to tolerate higher levels of metal stress. And interestingly, plants that naturally accumulate a lot of silicon like grasses, rice, sugarcane, often seem to benefit more from these internal mechanisms.
Okay, can we get specific? How does it work for different metals? Say, aluminum, that could be toxic in acidic soils.
Good example. For aluminum, in plants like corn and barley, silicon promotes the formation of hydroxyaluminosilicates in the root tips. Basically, inert compounds that reduce aluminum's mobility.
Immobilizing it right at the entry point.
Pretty much. In peas, researchers have seen silica layers forming on the outer root cells, which seem to absorb aluminum. And in rice, it decreases how much aluminum gets bound up in the cell walls in a harmful way.
Wow. What about cadmium? Another nasty one.
With cadmium, silicon seems to reduce its movement from roots to shoots in rice, partly by trapping it in the root cell walls through stronger binding. It also, as you mentioned earlier, ramps up those antioxidant enzymes in plants like wheat, peanut, and cotton under cadmium stress, helping to manage the damage. Plus, evidence suggests silicon helps form physical barriers in the roots of wheat and rapeseed to block cadmium entry.
And zinc. I know zinc is essential, but too much is toxic.
Right. For zinc toxicity, silicon can cause it to co-precipitate with silicon in the outer layers of leaves in some plants, like rice and spring sandwort, effectively taking it out of action.
So locking it away safely again.
Yes. And externally, in the soil, silicon application can reduce zinc bioavailability too.